Good morning, everyone. This is Mr. Rowe and Miss Cruey.
Hello.
We are here to go over some EOC review problems. These are the state-released problems. So pay attention to these. At the end of the presentation, you'll be given a document with your assignment that you're going to turn in. Please follow the directions on that assignment to make sure you get credit. This will be lesson 22. Is that correct?
Yep, 22.
All right, so let's get started. So like I said, these are released problems that the state has said this is how you're going to be tested. There's number one. All right, so here is the first problem. It says the density of an object is related to its mass and volume. The equation below shows the relationship between density, mass, and volume. And you're asked to find which equation represents the volume of an object in relation to its density and mass. All right, Ms. Cruey, what you got? What's thinking about this?
Well, we did literal equations that we talked about on the first review session. This is a perfect example where you have to choose a different variable to solve for. And for this one, it's v. Since v is in the denominator of the fraction, what do we need to do? Well, it needs to be by itself. We can't divide by v because we're already dividing by v. So we need to undo that fraction to start with, right, Mr. Rowe?
That's right.
Okay. So in order to undo the fraction, we would have to multiply by v, because to undo division, you have to multiply.
Yes, we're going to multiply both sides by v. That seems like a backward step since we're trying to solve for that variable, but that's what we got to do. We can't have our variable as a denominator.
Right. So we get it out from underneath, and then it becomes just an easy one-step equation here. We are multiplying v times d. So in order to undo that, we divide by the d.
And so that's going to give us that the volume is the ratio of the mass to the density.
There we go. And that would be choice D.
All right.
Next.
So here is number 2. He talks about Emilio. He's got a triangle. He says he represents the perimeter of the triangle with the equation. And then you want to solve that equation for W.
Okay, so the first thing we have to do is we have to simplify. So we need to look and see if you remember simplifying equations or expressions. The first thing you need to do is any distribution that you can. So here we look at the equation as it's written, and we can distribute the 2 to the 5w plus 15. Since there's no distribution to do to the other two sets, Mr. Rowe is rewriting it without the parentheses because we don't really need them. They're just representing the different sides. So when we distribute 2 to 5w plus 15, we get 10w. 2 times 5w is 10w. Plus 2 times 15 is 30. Okay, and now we've got to find our like terms. So let's start with the w's since 5w is first. We want to find all of the w's and combine them. I usually do what he's doing and circle them to make sure that you get them all. So 5w plus 2w plus 10w gives us what? 17w.
17 w's.
Okay. And then you take the constants. We've got a negative 13. That was 5w minus 13. When we combine everything, we have to take the sign in front of the term with it. So that minus 13 becomes negative when we're combining our constants. Negative 13 plus 6 is negative 7 plus 30 is plus 23. Okay, so now here's something that you can, if you look at the choices, the answer choices, you see the only one that has a 17 and a 23 in it is A, so probably that's going to be your answer. But we want to go ahead and work through and solve it just to make sure that we're right. So to solve this for W, we would subtract the 23 from both sides. Okay, that would give us 17W equals P minus 23. We cannot combine those because they're not like terms, so it stays an expression. And then we divide the whole thing on both sides by 17. And sure enough, A was the correct answer. Okay, so pay attention to little, that's just a test taking strategy. Look at your answers. If there's any that absolutely don't make sense for that problem, you can probably eliminate them and focus on the ones that do. But always, 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 because this is an untimed test, work through it all the way and make sure that that's right.
That's absolutely correct. And I love what she did was she stopped after the first step right here and said, well, let me look. And sure enough, we had kind of eliminated everything else. But like she said, keep working until you get to the end.
Yep.
All right. So Kaylee is building a rectangular enclosure with an area of 90 square yards. She wants the length of the enclosure or the enclosed area to be 6 yards longer than the width. And to represent this, she writes the equation x squared plus 6x equals 90. She then completes the square. That's something we've got to talk about to help her solve the equation. And then which equation is equivalent to Kaylee's equation after she completes the square? So we're going to take that equation right there, x squared plus 6x. Now I'm going to leave a little space there for my completing the square step. So how do you complete the square?
Look at your middle term.
We look at this term. We look at this term, and we're going to find half of b, or b divided by 2, however you want to look at it.
And b is the coefficient of that x term, right?
B is the coefficient of x, which in this case is 6. So half of 6 is 3. And so what do we do with that 3? To complete the square, we add 3 squared to each side. So that completes the square. And then we can simplify it, and let's look at our answers over here after we simplify here a little bit. What's 3 squared?
3 squared is 9.
That's 9, so that's going to be 90 plus 9, which is 99. So again, I'm going to do what Miss Cruey did, and I'm going to look at my answers here. That's the only one that's got 99, so I'm thinking it's that one. So
but we have an untimed test, so there's no reason to rush to judgment.
Right. I'm going to simplify 3 squared on this side and get 9. I'm going to factor this. Well, the factors of 9 that add to be 6 are 3 and 3. So this will be x plus 3 squared equals 99.
There we go. Once again, we were right.
All right, this is another, looks like completing the square problem. It says it completes the square and rewrites the given equation. Which one is equivalent? So if you didn't take the time to go over completing the square when we had those lessons, you might want to go back and review that, because like I said, these are released questions. So the state seems to think completing the square is important. So what's our first step here, Ms. Cruey?
We're going to move that 37 to the other side.
So we're going to do that by subtracting 37 from each side.
And that'll give us a hole there, a space in that equation to complete that square.
And like we said on the last problem, to complete the square, we're going to look at the coefficient of the linear term, the x term, which is b. So half of, in this case, 14, which is 7. To complete the square, we add 7 squared to each side. All right, so 7 squared, 49. And so we got negative 37 plus 49.
Mhm. That gives us 12 on the right.
That gives us 12 on the right. And if we go and we try to use our little tricks here, what's a couple of tricks we can use here, Ms. Cruey?
Well, if we want it equal to 0, we would have to subtract the 12 from both sides. So we can go ahead and we don't even have to do all that step yet, but you can eliminate C and D because 12 is added. And when we subtract from both sides, we're going to have either A or B as our choice. And then we need to factor the trinomial there, x squared plus 14x plus 49. And if we look, all of our terms are positive. So if everything's positive, we can't really have a negative.
Yeah, so I'm thinking x plus 7 squared. The only x plus 7 squared of the ones that we've got left
Would be A.
is A. And so I think that's the right answer.
It is the right answer. Okay, so again, use test-taking strategies. Eliminate things that you know won't work.
Absolutely. All right, so we got a linear inequality here. So we're going to, we talked about how to graph an equation. Was that session 2 or session 1?
2.
Okay.
One was writing equations. 2 is graphing.
All right, so that was session 2. So to graph an equation, just the equation part, remember we're going to try to use M and B to help us out.
Mm-hmm.
And in this particular problem, if we treat this like it's y equals negative 2/3 x plus 2, our M will be negative 2/3. That's our slope. And our y-intercept will be that positive 2. So the first thing I want to do is I want to look at all of my equation or all my graphs, and I want to find and make sure, number one, which ones have a negative slope.
Yep.
So which ones can we cancel out just because they don't have negative slopes?
We can cancel A and B because those are both positive.
So those have positive slopes.
Mm-hmm.
And so if we take a look at the other two, can we eliminate either one of these just because of the y-intercept?
No, we cannot. They both have the same y-intercept.
Both have the same y-intercept.
They are the same line.
Yeah. Another thing that we could look at, but in this case, they all are the same, was if it was a dashed or solid line. In this case, because it's greater than, we should have a dashed line. Well, they're all dashed, so we can't cancel because of that. So now we have to see which one is shaded correctly. So what's your tip for shading here?
Well, the best way is to take, if the origin is not part of your line, take the origin 0, 0, plug it in, and see if it's true. If it's true, then you shade the side with the 0, 0, the origin. And if it's not true, then you shade the other side. So when we plug 0, 0 in here, we get 0 is greater than 2.
I'm going to show that real quick here. 0 and then plus 2. So that negative 2/3 times 0 is 0. So 0 would have to be greater than 2.
Which is not true.
Which is
so
not
we
true.
Don't shade the 0, 0.
So we don't shade the 0, 0.
So it can't be D because 0, 0 is shaded there, right?
Right. So it's shaded on that one. So that one's out.
It has to be C.
That as our answer.
Okay, so for those inequalities, you check the shading, you check your slope, check your y-intercept, and check whether your line is solid or dotted. Here we go again.
We got another one. This one's in a different form, so we've got some other things that we can probably try to do here. I like.
Well, we talked about graphing, and this is in standard form, so we can look at the intercepts, find
so
the
we
x
can
and
look
y
at the
intercepts.
Right. So we got 5x, and I'm gonna go ahead and set up a little equation. 5x equals 10.
Because if it's the x-intercept, then the y value is 0, so that y term drops out.
So I'm kind
And
of
to find the x-intercept,
this crew is filling in for me.
the y-intercept, we plug a 0 in for x, so that 5x drops out and gives us this negative 2y equals 10. So we're going to find the x and y intercepts this way.
So this will be the x-intercept, which will end up being, if we divide both sides by 5, x would equal positive 2. And the y-intercept, if we divide both sides by negative 2, we get y equals
Negative 5.
So we want to look first for a graph that has 2 for the x-intercept and negative 5 for the y-intercept. So
and again, that would...
Go ahead.
Well, C and D are the only ones that have negative y-intercepts.
Yeah, so that's what I was about to say. I was going to cancel out A and B because they got positive y-intercepts.
Yep. So now we can't, they both have a positive slope. We don't have our slope anyway, though. And they're both solid lines. So we just have to check our 0, 0. Check that point. When we plug a 0 in for x and y, both of those terms drop out, and we would end up with 0 is greater than or equal to 10. Again, that is not true. So we don't shade 0, 0. We would shade the other side. So C would be eliminated because 0, 0 is shaded. And D is our answer.
Now, did you finish everything you were saying about the linear inequalities?
I think so, yeah.
Okay, all right, good. All right, here's number 7. When Mark hits a tennis ball in the air, he uses the equation shown to approximate the height in feet of the ball 2 seconds after it gets hit. What does the 4 represent? So we want to know what this thing right there represents.
Okay, well, let's just look at all the choices first and see if there's any we can get rid of. What do you think?
I like that idea.
Okay, so if T represents the time, we can look at A. It says the ball is in the air for 4 seconds. Well, that's time. T represents time, though. The H, well, what am I trying to say, Mr. Rowe? You know what I'm trying to say.
H represents height. So this whole equation has to represent something with height.
Okay.
So
yes.
if it's talking about 4 seconds, well, that wouldn't make sense in the equation.
Right.
Is that what you're trying to say?
Yes, that's what I was trying to say. Thank
we
you.
can eliminate that one because it doesn't make sense with the equation.
Right. Okay,
Right,
all
so-
the other 3 are all talking about a distance. So they're possible.
Yeah, so these are possibilities. Now, something you can go back and kind of review is any time you have one of these equations, this middle term is the initial velocity, and then this term is the initial height. So that's something that was discussed in one of the lessons. So let's see if we can use that to figure out which one of these choices is the correct choice. So which one looks like it's right, Miss Crew?
C.
Yeah, I'm thinking it's C too. So, because it says it was 4 feet above the ground when it was hit. So when it was hit is the initial height.
Right, that's where it starts.
Yeah, so that's the starting point.
If you look at B, it doesn't make any sense. The ball landed 4 feet away. We're not talking about the distance away. We're talking about time and height. So if that one's not talking about height, that's not even a possibility.
Right. And D, then ball reaches maximum height 4 seconds. Again, they're kind of talking more about time here. That wouldn't make sense in the equation.
Right.
All right. So this website tracks the number of users it has at the end of each of its first 30 days. And then they give you an equation, y equals 15 times the quantity 1 300ths to the x power. And that shows the relationship between the number of days since the website went online and the number of users it has. What does the 1.03 represent? So again, we kind of want to look at our choices here. And again, when we got exponential problems, we've got an initial quantity. And that's kind of the general form there.
Yep.
1 plus R is the rate of increase. If it was a decrease, it would be 1 minus R. And then T is the time. So in this case, the 1.03 probably means which one?
Probably C.
Yeah, probably C, because it's a 3% increase.
And you would, that 1.03 is 1 plus 0.03, 3 100ths, right?
Right.
You can break it down and just take that decimal portion and realize that that is 0.03 written as a percent, because you move your decimal 2 places to the right, would be 3%.
Now this is the over here. This is the general
Rule?
growth and decay rule. I was trying to think of growth and decay.
Oh.
This would be a growth problem because it's getting bigger. So 1 plus R. If it was a decay, it would be 1 minus R.
Yep.
All right, so we got a quadratic expression, x squared minus 100. Which statement best explains why the quadratic expression can be written as x plus c times the quantity x minus c?
Well, all of those are true. So we can't really throw anything out. But it says which one best describes it. Best describes is probably going to be something you've heard quite a bit. So I would say B. It is
And
the
we had a
difference
whole
of square.
lesson on pretty much factoring and difference of square multiplying. So that's a big concept. It's one of the easier things that we do that students tend to not think about because they don't see it. But the difference of squares is that thing you need to keep in the back of your mind all the time. So that is definitely a difference of square.
Yep.
All right, so which expression is equivalent to x to the 4th power plus 6x squared plus 9? Well, let's look at some of the answers first.
Mm-hmm.
I'm getting rid of this one and this one.
Why are you getting rid of those, Mr. Rowe?
Because this has 3 terms, and if I have an x plus 3 to the 4th power right here, I'm going to end up with more than 3 terms. That's going to be x plus 3, then I have to write out 3 more terms.
And I'm going to get rid of A.
Why are you going to get rid of that one?
I'm going to get rid of A because if I square this, my first term is going to be x squared, not x to the 4th.
Yeah. So x plus 3 times x plus 3. If we multiply those two using FOIL, we get x squared. Well, we need x to the 4th.
Right.
So looks like the only one left is C.
Let's see. and another trick here, because it's untimed, if you can't remember the rules, take these binomials, write them out, and actually do that. Complete the foiling there and see if you get the expression that's in the problem.
Yeah, so this is technically a perfect square trinomial.
Mhm.
Well, it is a perfect square trinomial. It's just that the exponent is 4 instead of 2, which we usually see.
Right.
All right, so this kind of looks like one we just had. So let's see if it's something similar. It says the function f of x equals 4 times the quantity 5/10 to the x power. And it gives the remaining amount in grams of a radioactive substance after it's been decaying. That's a key word right here. For x minutes. What does the equation f of 4 equals 2500 represent in this situation? So this is a rate of decay problem. We just talked about a rate of growth problem, so it's kind of similar.
Okay, so since we have f of 4, that just means that in the place of x, we put a 4. Okay, so what it's going to give us, and if you look at the very beginning, it tells you that the function gives the remaining amount, right? So if we work this out, you've got a calculator, you can do that. You would get f of 4 equals 2500, 0.25. And we know that that is the remaining amount. So if we look at the choices, the first two are telling us our time is 15 seconds and 25 seconds. Well, that's not right. We're working in minutes. X equals minutes. So we know that we're supposed to have 4 minutes. So it has to be C or D. C tells us that we have 0.25 grams remaining, which that sounds pretty good. But again, it's untimed. Let's check the other one just to make sure. This says 25% or 0.25 of the original substance, original amount. Hang on, I'm reading the question again. Is the remaining amount of substance after it's been decayed?
D is going to be wrong because it doesn't give you the quantity.
Right.
It says
okay. It's telling us the percent.
It's telling you a percent of the original substance. Well, that's not what's remaining. This
Right.
is the amount that's actually remaining. So right. C is going to be the only.
Thank you.
Those get me too, don't worry.
I know. I was like, wait a minute, let me read this question again and make sure I'm answering it right.
All right, so this time Reggie carves and sells wooden sculptures online. He uses that function to determine his selling price. And that's for a sculpture that took him X hours. Which statement explains the meaning of the value F of 75?
Well, if X represents hours, to me, there's only one choice here. F of 75 means that we're talking about 75 hours.
I'm good with that, Ms. Curry. That's
yeah. Just make sure you're reading the question.
Yeah. Pay attention to what it's saying. You know, it says that X is the number of hours. So anytime it tells you anything else about hours, like 1 hour, 5 hours, well, that's not 75. So those couldn't be right.
Right.
All right, so we got a quadratic equation that says the function has 2 x-intercepts. What is the equation of the function's axis of symmetry?
Okay, and we talked about this with quadratics. If you can find the x-coordinate of your vertex, that is your axis of symmetry. And to find that, yes, negative b over 2a. So you look at your coefficient of x squared is A, your coefficient of x is your B. So in this case, we get negative 14. Don't forget to pay attention to those double negatives over 2 times 1, which is just going to give us 14 over 2, which is 7. The 7 is our axis. X equals 7 is the axis of symmetry.
And this one is estimated as a high difficulty problem. But if you just know that one little thing there, it's a pretty quick problem.
Yep.
Ooh, that was big. All right, so let's take a look at this one. Quadratic function is shown. Y equals x squared minus 14x plus 30.
It's the same thing.
That's the same one. I did that one twice.
Yeah, looks like it. Moving on.
Mr. Rowe with your silly tools. Is that the same one? No, that's different. Which equivalent form of g of x equals 2x squared minus 12x minus 54 is the best form to find the zeros of the function?
Ooh. I think C.
Yeah. C is the only one that's factored.
Right.
So if you talk about zeros, this was the lesson on quadratic equations with the graph. If you look at a parabola, the zeros that we're talking about is where the graph crosses the x-axis.
Right.
And so that's why we factor. That was one of the reasons that we learned to factor, was to find those zeros. So C is the only one that makes sense. Which situation can be modeled by an exponential function? All right, so remember we got linear, which will look like this. We've got quadratic. We've got exponential. So we want to focus on one that would be best described by exponential like that, y equals a to the x. So let's take a look at the situations. A says photos cost 8 cents each. Well, that's not going to give you an exponential curve, because if you think about the table, one photo is going to cost 8 cents. 2 photos will cost 16 cents. So that's definitely not going to be exponential. It's not going to change.
At the same rate of change.
Yeah, it's not going to increase the rate over the time. The population of the town increases by 3% each year. I kind of like that one. So let's
I really like that one.
Let's star that one. Let's take a look at the other two though. The pay of an employee is $12.25 an hour plus 5% of sales. So
we're adding something each time.
Yeah, we're adding something each time, but it's still an each. An hour kind of makes that one not exponential.
It's going to be linear if you think about it.
It's going to be linear.
Because that, well.
Depends on your sales.
Right. That's what it depends on sales. So
it might be more of a jumpy graph.
Yeah.
And then the number of gallons of water in a tank decreases by 52 each day. So that's a constant rate of change. Yeah. Constant rates of change are not exponential. B gives us our only possible choice here.
Right. It's increasing 3% each year. And you might say, well, that's constant because it's 3% every year. But the the population that you're calculating your 3% is going to be increasing every year. So
For
each year your
example,
increase is going to be more.
you know, year one, you got 100 people. Year two, you'd have 100. Is that right, Ms. Crewy?
Yes.
And so we're going to base our increase the following year on this value, not this value. It would be 3% of 103. So each year you base it on the year before.
Yep.
All right, this one looks like it's got a lot of words.
Oh, goodness.
There we go. No. Now we're cooking with gas. All right. So Victoria and Roberto are climbing stairs in a tall building to raise money for a charity. So they're raising money together as a team. Victoria and Roberto receive donations differently. This is probably some important stuff here. Victoria receives donations from people who give a fixed amount for each flight she climbs. Roberto receives donations from people who give a fixed amount regardless of how many flights or stairs he climbs. Victoria and Roberto write an equation to represent the total amount their team raises, y, based on the number of flights of stairs Victoria climbs, x. Which is the best statement to describe the equation?
Okay, so let's see if we can eliminate any yet. If she's getting a fixed amount for every flight of stairs that she climbs, this isn't going to be an exponential function.
Yeah.
So we can eliminate
It's not
C.
exponential, so we can C and D are gone.
Mm-hmm.
So we got narrowed down to A and B.
Okay, and if we look at A, it says that the money does not depend on how many flights of stairs Victoria climbs. Well, that completely contradicts what the problem says. It says she gets money per flight of stairs, right? She gets a fixed amount for each flight of stairs that she climbs. So it does depend on how many flights. He's the one that it doesn't matter how many he climbs. So B is the answer.
There you go. Process of elimination.
Yep.
Using what it says in the problem and understanding that because it says each instead of some kind of other, what would a word be to make it exponential?
She would have to receive more money based on climbing more flights of stairs. Like if she gets $10 for the
She gets
first,
an additional dollar for each flight she climbs.
for each flight. There you go. Yeah.
All right, so Central High School has 1,023 students. Approximately 75% of the school's students attend the last home football game. Which attendance number is the most appropriate estimate for the school's students who attended the last home game?
Well, we're estimating, so we probably aren't going to have decimals in our answers.
Yeah, I'm all in favor of that.
And so I don't know, Red, what do you think?
Well, I honestly think both of them are good estimates.
Yep.
I would actually, if it was me, I would pick A, but when in doubt, I'm looking at the answer.
Well, the answer is going to make us even more confused. The actual
we got
answer.
1,023. And we got 75% attended it, so 0.7 times 0.75. And so 767.25. So this
that's the
really, to
exact
me,
number.
is not an estimate.
Right. But it's just rounded to the nearest whole number.
It's rounded
is
to the
what we
nearest
take
whole
here.
number. I think that's a poorly written question.
I do too. We wouldn't give you one like that.
No. All right, so we got an expression, the fourth root of x to the fifth power. Which expression is equivalent to the given expression?
Okay, so think about the roots of a plant or a tree are underground, right? So when you're writing these if we're writing it, the equivalent expression, we do not want to use the radical. We want to get rid of that radical.
Yes,
So
these are
A and
already
B
going
we
to
can throw out.
We can throw those out.
So we want to know what is the fraction that would show the fourth root of x to the fifth power. Well, the root goes underground. So put that root under the fraction bar. So it would be x to the 5/4 power.
I like that explanation.
Oh, you haven't heard that before?
I'm going to start using that one.
Good.
Learn something new every day.
There you go. All these years and I've never shared that with you. What?
No, I just remember Gilligan's Island, or what was that?
I don't know.
Where you came in and sang the quadratic formula or something.
Oh, yeah. It wasn't Gilligan's Island. It was Pop Goes the Weasel, right?
I don't know. I thought it was Gilligan's Island. All right, so which expression is equivalent to 86 times x to the half power times y to the 2/3 power?
Okay, so you can use my same explanation from before. The root is what's underneath.
Can we look at some answers first?
Yeah.
Can we cancel these two out?
Yep. Yes, sir.
I'm canceling those two out because 86 does not have an exponent or a power or anything. So it can't end up in the radical.
But a lot of people would look at that and think it is. So just remember that exponent is only attached to one thing. If that 86 were included, there would have to be parentheses around 86x.
Yeah, so it would have to be this. And then x.
Right. But since there's not, the 86 does not have, it's not going under any kind of radical. All right, so the 86 has to be out front, so it has to be A or B. And then we look at the x. It's x to the half power. Well, that root is 2. So that means the square root of x. Well, both A and B have square root of x. So move on. Next, we've got y to the 2/3. Again, remember, the root is underground. So we need the third root, or the cube root of y squared. So A has to be our answer.
And me just thinking about it, I see 2 and 3 right here, which is my fraction.
Mm-hmm.
So I would have eliminated B just because of that.
But B has an understood 2, remember? Because
Yeah, but
if it's you don't see it there.
Yeah, the 2 should have been the power, which is your rule, the power.
Right. Is this our last problem?
This is the last one.
Woohoo! Moving on. Good. All right.
Annabelle collects litter alongside a road near her house for 8 days. She keeps track of the number of plastic bottles X and aluminum cans Y. She finds alongside the road for each of the 8 days she collects litter. And then her data is in this scatter plot. Because the correlation coefficient of the data is 0.78. Which relationship between the number of plastic bottles and the number of aluminum cans best describes the meaning of the correlation coefficient? All right. Just knowing if you know, don't even understand the word correlation coefficient, you ought to understand positive and negative.
Yep.
So if we kind of do that through the data, that's not a great line there, but I'm just trying to give you an idea. That is a positively sloping line.
Mm-hmm.
So I want to cancel out anything that has anything to do with negatives. So those are gone. Wait a minute. Canceled out one. I should have canceled out there.
Yep.
I wanted to cancel out
BD.
and that one. And so now we've got a choice between a weak positive relationship and a strong positive relationship. So what's your thoughts there, Ms. Cruey?
Well, the closer that your correlation coefficient is to 1, the stronger the correlation.
Yeah, so that's to me, once it gets past like a 0.5 right there,
Then it would become strong.
I'm going to go ahead and say strong instead of
Yeah.
weak because that's my two choices.
Yep.
Once you get into statistics, you'll get a little deeper talks about that. So but that's a strong positive relationship.
There we go.
All right. So make sure you complete the assignment that you're going to be given. It's going to be on a Google Doc. Submit what we ask you to submit. Make sure you show all your work to earn full credit. And this is lesson 22,
Two.
right?
Yep.
22.
Have a great day, guys.
Have a great day.